All right, so section 6.4 is on rhombuses, rectangles, and squares. So a rhombus is a specific type of parallelogram. It's a parallelogram with all four sides congruent. So all four sides congruent. So when you guys were in elementary school, you probably called this a diamond. Okay, so it's just basically a diamond shape. A rectangle is a parallelogram with all four angles congruent. So what would those four angles have to be equal to? Like each of them is going to be, yeah, all are 90 degrees. And then a square is a parallelogram that has both of those characteristics, right? So all four sides and all four angles congruent. Okay, so we sometimes say that the square is the baby of the rhombus and the rectangle. It has all the characteristics of a rhombus and all the characteristics of a rectangle. All right, so it says try to draw an example of a rhombus, a rectangle, and a square. So a rhombus is going to be something like, oops, like this, where all four of these sides are the same. A rectangle is going to be something like this, where all four of these angles are the same. And a square is going to be something like this, where all four angles are the same and all four sides are the same. Okay, so a square is by definition both a rhombus and a rectangle. Okay, it's both of those. All right, does this make sense? All right, so we're going to decide whether this statement is always, sometimes, or never true. So draw examples if needed. So is a rhombus a rectangle? So I just told you that. False. Why? Yeah, so a rhombus doesn't necessarily have like 90 degrees, but could it? Yeah, so it could have all four. So we're not going to say totally false. It's not always false. We're going to say sometimes. Say rhombus could be a rectangle if we had a square. Okay, that's a type of rhombus that is also a rectangle. Okay, a rectangle is a parallelogram. So does a rectangle always have opposite sides are parallel? Yeah, that's always true. Is a parallelogram always a rectangle, though? No. So we're going to say sometimes. It could be a rectangle, right? So we're going to say sometimes. Is a rectangle a square? Is every rectangle that you draw a square? No. Are some of the rectangles you draw, they might be a square? Yeah, so we're going to say sometimes. And then a square is a rhombus. So does a square always have all four sides congruent? Yeah, so that's always. Those can be tricky for students, always, sometimes, and never. All right. So EFGH is a rectangle. So let's sketch it out. It doesn't matter where you start it, but go in order once you start it. And K is the midpoint of FH. So FH is going to be this diagonal, and K is going to be in the middle of it. It says EG, this total length right here, is 8x minus 16. So what are EK and GK in terms of x? Okay, so let's think about a rectangle. So if I had a rectangle using pad and paper, did I skip something? Did I skip something? No? All right. What do you think? So we talked about parallelograms before. Like if I have a parallelogram, like maybe like a rhombus shape, that's a parallelogram. Do you see how the diagonals aren't the same length? This length is not possibly the same as this length. But what about a rectangle? If I cut that rectangle in two pieces, and then I decided that I was going to cut it this way instead, would those two sets of triangles formed, would they be the same? Like if I cut it into this one and this one, right? I have my two triangles. And then if I cut it into the blue triangles, so this one and this one, would all of those triangles be exactly the same? You guys understand that, right? Just from like what you've done in elementary school with like cutting out pieces of paper and so on. They're the same. Okay, so what does that mean about the diagonals then? It means this diagonal is the same length as this diagonal. Okay, so that's specific to a rectangle. A rectangle has diagonals that are congruent, but a rhombus clearly doesn't, right? Okay, so in this problem it says that we have the total of 8x minus 16. So what are EK and GK in terms of, I guess I didn't need this theorem in the first place. EK and GK have to be half of what we had originally, right? So what's half of 8x minus 16? Yeah, 4x minus 8, right? I just told you diagonals were congruent, then I didn't even use it. I thought I was going to ask for FK and H. So what if I ask for those? FK and KH. Well, they're going to be exactly the same. They're both going to be 4x minus 8 as well, because the total length was the same. All right, so it says in the diagram on the right, ABCD is a rhombus. What is the value of x? So if we have a rhombus, what's the definition of a rhombus? We said that all four sides must be congruent. So whenever you see something's a rhombus, we draw on our tick marks. We say, okay, all those are congruent. So that means that 2x has to equal 3x minus 16. So negative x equals negative 16, so x is 16. So you got to be really good at whenever I say, like, this is a rhombus, this is a rectangle, you got to be able to draw on some markings. All right, so this is a square. So what markings do we draw in? Well, a square has all four angles or right angles. So that gets us an equation, right? Do we see how 8x plus 10 has to equal 90? So it was down here. So we can solve. So we're like, okay, subtract that 10 over, we get 80. 8x, so we get x equals 10. But with a square, we also know all four sides are right, or all four sides are congruent. So we're going to set all those sides congruent to each other. So now we have 2y has to equal x plus 4. So that's where we take our x equals 10 and we plug it in. So we say 2y equals 10 plus 4. So 2y is equal to 14. So then y is equal to 7. Easy enough? Not a hard section. All right, so now we get into the things that we have to, like, you have to just memorize these. You have to know these properties. Okay, so a parallelogram is a rhombus. Well, let's think about a rhombus shape. So if you draw that diagonal, or that, not diagonal, the diamond shape all the time, look at the diagonals. The diagonals are not congruent to each other. But those diagonals are perpendicular to each other. Do we all see that, like based on our picture? So our diagonals are perpendicular. So it's an if and only if statement. So if we go all the way back to chapter 2, do you guys remember when we say if and only if? That's called a biconditional. That means the statement works forwards and backwards. So I can say if a parallelogram is a rhombus, then its diagonals are perpendicular. If a quadrilateral has diagonals that are perpendicular, then it must be a rhombus. Okay, so we work forwards and backwards. All right, a parallelogram is a rhombus if and only if its diagonals bisect a pair of opposite angles. So looking at my figure over here, look at these angles here, 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 and here. Does it look like they bisect those angles? So we have this and this are congruent. This and this are congruent. Does it make sense? These are congruent, and so on. And then a parallelogram is a rectangle if and only its diagonals are congruent. So I kind of explained that to you already. So if the diagonals are congruent to each other. Okay, so we got those three properties. Think you guys can memorize those? All right, so let's find the numbered angles in the rhombus. So whenever we see it's a rhombus, we're like, okay, rhombus means all these sides are congruent. It means our diagonals are perpendicular. And it means that all of these angles are bisected. And not only are they bisected, but since it's a parallelogram, they're also congruent to each other across the parallelogram shape. Okay? So let's go through our angles. So we have the measure of angle 1 is equal to something. We want the measure of angle 2, 3, and 4. All right, let's start with the easy one. What's the measure of angle 2? 90. Got that. So if we have a 90 here, and we had 58, 58, 90, and something make 180, right? We need to find this little angle right here. What's that angle have to be? The easiest thing to do, what I will always do, is I don't add them to be 180. Instead, I take out the 90. And I'm like, 58 and what number are complementary? 58 and what make 90 degrees? 32. Yeah, so it's going to be 32, right? So we're going to have 32 in each of these spots. This is going to be 32 as well. And this one are also going to be 32. Do you see why? So 1 and 4 are 32. So now all we have left is angle 3. And what's angle 3 have to be? 58. Perfect. Okay. I'll put my little degree marks in. All right, same idea on this one. So we have a rhombus, so we know all 4 sides are congruent. We know our angles are bisected. And then opposite angles are obviously congruent to each other because it's a parallelogram shape as well. All right, so the measure of angle 1 is 118. But we still need to find 2 and 3. So do you guys remember the isosceles base theorem? So an isosceles triangle, if I had 118 here, and I have markings that say it's congruent, these 2 pieces are the same. Okay, these angles will be congruent to each other. Okay, so I'm going to have 118 plus x added to another x equals 180. So I have 2x equals, if I subtract the 118 over, 62. So x equals 31. So that means this angle here and this angle here are both 31. The measure of angle 3 is 31. What do you guys think the measure of angle 2 is? 31, right? It has the same markings. It's congruent, so we get 31 as well. Okay, does this make sense? All right, so find the value of the variables in each parallelogram. So we have RZ is equal to 2x plus 5. And SW, this whole thing, oops, that's a bad brace, is 5x minus 20. Okay, so we need to set up some kind of equation. So what do you guys think our equation is going to be? Oh, so we have a 90-degree marking. Since the opposite sides are congruent, this is also 90 degrees over here. And since opposite or consecutive angles are supplementary, these are both 90 degrees. So what shape do we have? So it's not just a parallelogram, it's a rectangle, right? Okay, and we're talking about the diagonals. So not only do the diagonals bisect, right? So diagonals bisect each other. Because it's a parallelogram, right? But what else is true about the diagonals for a rectangle? They're congruent to each other, right? So our diagonals are the same length. So when I have 2x plus 5 here for RZ, what is ZT? 2x plus 5, right? Because diagonals bisect each other, so this piece has to equal this other piece. So what's the whole length going across? Yeah, exactly. So this piece right here, this ZT, is also 2x plus 5. So this whole length is 4x plus 10. So our diagonals are congruent, so we're going to say 4x plus 10 has to equal 5x minus 20. They have to be the same. So I subtract my 4x over and get x. I add my 20 over, I get 30. So x is equal to 30. All right, so same thing. So BD, so I have BD is equal to 4x minus y plus 1. Okay, and I have some markings drawn in. So what shape do you think this is based on the markings? It is a square. Do you guys see how we would have to have 90 degrees across from it? Opposite angles are congruent, but consecutive angles are supplementary, so we'd have 90 and 90. And then we have these markings that mean we're congruent, so if those two are congruent, these two have to be congruent because opposite sides of a parallelogram are congruent. So if this whole thing is 4x minus y plus 1, and this other part, the sum is going to be like 2x minus 1 plus 3y plus 5. Why was I able to set those equal to each other? Why could I say those two diagonals were congruent? Because a square is what? A square is a rectangle. Do you guys understand this? So a square is going to have all those properties of a rectangle. So I'm going to write that out. So a square is a rectangle. So diagonals are congruent. Okay, so we definitely know this. So let's try to simplify. Let's get all our x's on one side. So we have 2x when I subtract the 2x over. I'm going to subtract my 3y over. So I have minus 4y. Let's write what I have right now. So I have plus 1 equals negative 1 plus 5. So over on the right side I have 4. But if I subtract that 1 over, I'm going to have 3. So I have 2x minus 4y is equal to 3. Okay, and it looks like we can't solve it because we're like, okay, I have x and y. So in order to solve an equation that has both x and y, we need a second equation that has x and y. So is there one more equation that we can get from here? What do you guys think? It has to do with the diagonals again. So diagonals are congruent, but diagonals also what? Bisect each other. So this part has to equal this part. So we're going to say, well, 2x minus 1 is also equal to 3y plus 5. So let's get everything on one side. So I have 2x minus 3y equals 6. Right, you guys see how I did that? I moved things around. And then I line them up. So I'm like, okay, I have 2x minus 3y equals 6. So I have these two equations that have both x and y. So do you guys remember how to combine them using Algebra 1? So substitution or elimination. This one I kind of set up nicely so I can do elimination. So what I'm going to do is the second equation, I'm going to multiply through by a negative 1. So when I do, I get negative 2x plus 3y equals negative 6. So I'm going to have negative plus negative. So now when I add straight down, my x's will go away completely, which is what I want. I want to have one variable in my equation. So x's go away. I get negative y equals negative 3. So y equals 3. So then once you have that, you go back to one of your equations. So 2x minus y equals 3y plus 5. And we plug in y equals 3. So I get 9 plus 5 is 14. I add the 1 over and divide, so I get x equals 7.5. So 7.5 and 3. Okay, does this make sense? Okay, so this one, so it says, it is given that PQRS is a parallelogram. Graph the parallelogram and decide whether it is a rectangle, a rhombus, a square, or none of the above. Okay, so plot your points. So what shape does it look like? It looks like a square, so let's count our sides. So our sides were 5. The bottom is 5. What about these ones? 4 and 4. So be careful. Don't say it's a square unless you know for sure. So what is it then? It's a rectangle, right? Okay. Does this make sense? You guys get that? All right.